Hey everybody, welcome back to lesson 1.4 where we're still looking at measures of variation. How spread out or closely grouped is our data? So in our last lesson, we looked at ways to find the average, the mean for a frequency distribution. We called it the mean for group data. Well, we can also find standard deviation and variance for grouped data. Now, here's the formula. But friends, we're not going to do that thing by hand. It's possible, but it's a lot because you're required to have a graphing or TI 8384 Inspire calculator in this class. Let me remind you instead of the calculator steps that we took. For our frequency distribution, we first had to come up with the midpoints for our distribution, the midpoints of our classes, and then we put those into L1, our first list. We put our frequencies into our second list. We were able to then run our one var, aka one variable statistics, and told our calculator that we had 2 lists. So let's go ahead and walk through that process together. For example, 3. It wants us to find the sample mean and sample standard deviation of our frequency table. As a reminder, we can't do this until we have our midpoints, because that's what we're going to put into our first list as our data values. So let's go ahead and calculate the midpoint of our first class. To find the midpoint, you take the bottom 0 and the top 2, upper and lower limits, and divide by 2. So 2 plus 0 is 2. 2 divided by 2 is 1. So our first midpoint is 1. Notice that the width of my classes is 3, right? The distance between each class is 3. So because of that, I don't have to keep calculating midpoints. The first midpoint is 1, 3 more, 3 more, 3 more, and 3 more. Gives me the midpoints of my 5 classes. So my midpoints, I'm going to put into my first list. My frequencies, I'm going to put into my second list on the calculator. So stats, edit. Let's go ahead and clear our list. So scroll up, clear, enter. And in the first list, I have a midpoint of 1, 4, 7, 10, and 13 for my 5 classes. In the second list, we'll put our frequencies 10, 19, 7, 7, and 2. Next, we're going to hit stats again. But remember, this time we're going to go over to calculate and go to 1 var stats. On both L1 and L2, we have to tell our calculator that we have 2 lists. So stats, calc, 1 var stats. List 1 is in L1, that's correct. But my frequency list right now is empty. So to get L2, you'll see it right here in blue, hit second, 2, and calculate. This one screen gives me everything I need. My sample mean, X bar, is 5.133 according to the calculator. And my sample standard deviation, remember that's the one with the S, is 3.402. 3.402. On both of these, let's go ahead and round to our nearest 10th place. So 1 decimal, a mean of 5.1, and a standard deviation of 3.4. Let's try one where we're having to interpret what these standard deviations mean for us. So Mark is looking into investing a portion of his recent bonus into the stock market. While researching different companies, he discovers the following standard deviations of 1 year of daily stock prices. The Profacto Corporation has a standard deviation of stock prices as $1.02. The Yardsmith Corporation has a standard deviation of stock prices to be $9.67. What do these two standard deviations tell you about the stock prices? Remember, standard deviation measures how well or how much we vary. So the smaller Profacto with the smaller standard deviation has a smaller variability, aka has less variability in stock prices compared to Yardsmith. Similarly, you could say that Yardsmith has a larger standard deviation, so it has more or greater variability in stock prices, aka there's more fluctuation. What do we do though if our standard deviations or our data aren't the same label, so to speak? I'm able to compare Profacto and Yardsmith because I'm looking at just money, stock prices and money. I'm comparing apples and apples. Yardsmith varies more, has more fluctuation in prices. Profacto has less fluctuation. However, in our next example, example 5, we're going to be looking at comparing rainfall and farmland. Well, rainfall is measured typically in inches. But yet land, specifically the price of land, is measured in dollars. So if I tried to compare these, because they are in different labels, it's not as easy. So before we do example 5, we need to back up and talk about the coefficient of variation. The coefficient of variation for a set of data is just a ratio of the standard deviation to the mean. It'll take the standard deviation, population or sample, divide it by the mean, again, population or sample, and multiply it by 100. That means it's actually going to be giving you a percentage. And this CV, coefficient of variation, is going to allow us to compare data when it comes from two different sources or two different categories. So if I look back at my example 5 again, suppose that graph A represents average amounts of annual rainfall for a sample of farms in the U.S. And graph B represents prices for 20 acres of farmland for the same farms. Now they were nice and went ahead and gave us the mean and standard deviations outright. The problem is, well, maybe looking at the graphs we can, but numerically, it's difficult to look and go, oh, I've got more variation here. I've got less variation here. So instead, we need to look at the coefficient of variation. Now let me pause just a minute. It is possible to talk about who has a bigger standard deviation, aka more variability, by looking at the graph. Notice how the big chunk of my data here is spread out wider versus this graph, the chunk of my data is a little closer together. I would venture to guess that this graph is going to have a larger CV, a larger coefficient of variation, and a larger standard deviation, more variability. And I'm going to assume that, guess that, because the middle chunk of my data is spread out more in the second graph than it is in the first. However, we don't want to just be guessing at this. Sometimes it's so close that we really do need those calculations to verify. So what we're going to do is we are going to take our mean and standard deviation that they gave us, and we're going to calculate their CVs. On the screen, I have a reminder of the formula for the sample that they've given us. Sample standard deviation divided by mean times 100. So for our first graph, I'm going to label that with a little a. I take my standard deviation, 7.55, divide it by my mean, 26.08, and times it by 100. Now, y'all, had they not given this to us, we could have calculated it, just like we did in our previous examples. Find those midpoints, find those frequencies. But here they were nice to us, so I can take 7.55 divided by 26.08 and multiply by 100, giving me 28.9% if I'm rounding to one decimal place. We now need to do the same thing for our second graph. Again, standard deviation on top, 42,931 divided by our mean, 117,000, and we're going to multiply that by 100. So 42931 divided by 117,000. Go ahead and get you an answer. When you multiply by 100, 36.69 rounds up to 36.7%. So we were correct earlier. This second graph with that bigger spread of my bars does have a larger coefficient of variation. So what that means is it is correct to say that there is greater variability. Let me write this out. There is greater variability in the price of farmland when compared to the rainfall. I know that because it has a greater percentage in that CV. More variation in price, less variation in rainfall. With that being said, I'm going to go ahead and stop this video here. We have one more to talk about, and that is the empirical rule that lets us estimate how much data falls within these standard deviations.